Hello, students and friends. Welcome to yet another interesting episode on our Prep Station online tutorial. And in this episode, we'll be looking at the topic gravitational fields. Now, what is gravitational fields? Basically, there are two types of forces. You have the force fields and then they have the contact fields. Now, force fields include magnetic fields and gravitational field. Why contact forces is just a push and pull. Now, what is a force field? A force field is a region where the effect of a force can be felt. And what is gravitational field? Gravitational field is a region around a mass or an object which the effect of gravitational force of the mass of the object can be felt. That is what gravitational field is. Now, let us look at what Newton's law of gravitation states. Gravitational forces that is operating between two masses, m1 and m2. Newton's law of universal gravitation states that the force of attraction or repulsion between two masses m1 and m2 is directly proportional to the product of the masses and inversely proportional to the square root of the distances between them. That is to say that if there are two masses m1 and m2, the force of attraction or repulsion between them is directly proportional to the product of their masses and inversely proportional to the square root of the distances that separate them. So now, if you have F with the proportionality sign M1, M2 all over the distance which separates them as D squared, if you remove that proportionality sign, we're going to introduce a constant which is called G. G is known as gravitational field constant. So if you introduce that constant, we're going to have F is equal to G into bracket M1, M2 all over D squared. So that brings us to the formula F is equal to G M1, M2 all over D squared. Now, let's look at a question that will require the application of this formula that we have mentioned just now. Now, two spheres of mass 5 kilograms and 10 kilograms are 0.3 meters apart. Calculate the force of attraction between them, given that the gravitational field constant is equal to 6.67 times 10 raised to power minus 11 Newton meter square per kilogram. Now, if you look at this question, there are a few parameters that are given. Our M1 is 5 kilograms, our M2 is 10 kilograms, while the distance that separates them is 0.3 meters. Now, if we introduce the formula that we just showed, which is F is equal to G M1 M2 divided by the square of D, we're going to have our G is 6.67 times 10 raised to power minus 11 multiplied by the two masses times 5 times 10 all divided by the distance that separates them, which is 0.3 meters. So if you plug these parameters very well into the formula, you are going to come out with an answer 3.71 times 10 raised to power minus 6 Newton. So if we go to the question and we look at the options, you notice that A is 3.71 times 10 raised to power minus 6, B 3.57 times 10 raised to power minus 2 Newton, C 4.0 times 10 raised to power 2 newtons, and C 3.50 times 10 raised to power minus 10 newton. So from here you can see that the correct option to that question is option A, which is 3.71 times 10 raised to power minus 6 newton. Now let's still take a look. Let's look at gravitational potential. What is gravitational potential? Gravitational potential V at any point is defined as the work done in taking a unit mass from infinity to that point. So gravitational potential is given as V is equals to minus G all over R. And the unit for that is joule per kilogram, where M is the mass of the Earth and G is the gravitational field constant, while R is the distance of that point from the center of the Earth. The negative sign indicates that the potential decreases as the object moves from infinity towards the Earth. So as the object moves towards the Earth, it's going to carry a negative charge. That shows that it's coming from infinity. Now, let's look at what is gravitational field intensity. Gravitational field intensity is the gravitational field on a unit test mass, E. Gravitational field intensity is the gravitational force field on a unit test mass. So E is usually F all over M. Now, from there, we look at what is escape velocity. Escape velocity is the minimum velocity at which an object is required to leave or just to escape the Earth's gravitational field. The minimum velocity at which an object is required to leave or escape from the Earth's gravitational field is what is known as escape velocity. And from there, the formula is derived, which is V is equals to square root of 2gm all over r, which is also equals to square root of 2gr, where g is the acceleration due to gravity, r is the radius of the Earth, and m is the mass of the body. So our escape velocity is usually given as square root of 2gm all over r, or you can give it as square root of 2gr. Now, calculate the escape velocity of a satellite launched from the Earth's surface. If the radius of the Earth is 6.4 times 10 raised to the power 6 meters, taking acceleration due to gravity to be 10 meters per second. Now, from this question, we notice that the radius of the Earth is given as 6.4 times 10 raised to the power 6 meters, while g is 10 meters per second. So, if we go back to our formula, which is v is equal to square root of 2gr, we notice that the square root of 2 multiplied by the radius of the Earth multiplied by gravity, which is 10. So, if we plug that in, we are going to have 11,303.7 meters per second. But if you look at the options very well, you see that the options are given in kilometers. So just to make it straightforward, we just convert this by dividing by 1,000, and that is 11,303.7 divided by 1,000 will give us 11.31 kilometers. Now, if you go back to the options, you see that A says 4.2 kilometers per second, B says 4.0 kilometers per second, C said 11.3 kilometers per second, while D said 25.3 kilometers per second. So the correct option to that question is 11.31 kilometers per second. Thank you.